Hi, I'm Steve Rentoul, and I'm speaking to you about Project 2.4, Changing Oceans in Australia's Future Climate. This is who we are. We really address all 5 of the Hub climate challenges, and I'll explain in the ways in which we do that a bit later in the talk. So what are we doing? First, we're exploiting the fact that measurements of the ocean provide the best thermometer and the best rain gauge we have to track changes in Earth's climate. As you know, more than 93% of the extra energy stored by the Earth over the last 50 years is found in the oceans, and changes in salinity provide the best evidence we have that patterns of evaporation and precipitation, the hydrological cycle, is changing as the Earth warms. Those changes in the ocean are important in part because they may modify modes of climate variability that dominate Australian climate, and that will impact on water, food, carbon, coasts, and extreme events. And we deliver that information to a wide variety of next and end users, researchers here and overseas, as well as at all levels of government. What have we done? 3 main things. 1, we've delivered the highest quality ocean data sets yet available to assess ocean change. We've measured ocean warming and changes throughout the full depth of the ocean. And we've developed climate models that illuminate the processes that actually drive ocean heat uptake. So as just a few quick examples, how do we know the Earth is warmed? Well, most of the heat's in the ocean, so that the main way we know that the planet is warmed is by measuring the oceans. And that's difficult because the instruments that have been measuring ocean temperatures have changed over time, and their quality and spatial coverage has changed over time. So getting a consistent climate record that extends back over the last century is not an easy task. So that's what IQUAD is doing, the International Quality Controlled Oceanographic Database Program. And Beck Cowley has been involved with them in constructing a true climate quality ocean database to allow that kind of work to be done. Esme Van Wyk leads the quality control project for Argo. Argo is measuring the global oceans, as you know, in a way that's truly unprecedented. There are now more than 3,800 floats active in the world oceans. What this project is doing is helping with the delayed mode quality control of that data to make it usable for climate questions like how rapidly is the ocean warming. Some examples of how we've used that information on the left is global ocean heat content over the last 50 years from the State of the Climate 2018 report. And as you can see, the ocean is pretty much steadily warm. There's not a lot of evidence of the global warming hiatus in ocean heat content measurements. That heat is entering the ocean, as you can see on the right. And the plot on the far right shows that most of that heat is accumulating in the southern hemisphere. And Nathan Bindoff and a student have recently submitted a paper that explains the physical mechanisms that are responsible for that southern hemisphere dominance. If ocean heat uptake is so important, our models better get ocean heat better reproduce ocean heat uptake pretty well, or else they'll get the wrong climate response. So Kyle Stewart and Andy Hogg have been looking hard at this problem and shown that they've identified the mechanism by which heat gets into the ocean. And part of that involves warming of the ocean, shifting of density layers to the south to the point where water is now experiencing different forcing from the atmosphere than it used to. And the result of that is warming on the northern side of the Southern Ocean and cooling a bit deeper down and further poleward. And that's a pattern that the models reproduce and that we also see in observations. So it's a hint that we're beginning to figure out how to get the models to simulate ocean heat uptake correctly. We've also looked in the deepest parts of the ocean. The map shows sections that have been occupied 3 times or about 3 times since the early 1990s. And they show a consistent pattern of warming in the deepest layers of the ocean. And in fact, they show that that warming has accelerated in the most recent occupations of those sections. Helen Phillips and Nathan Bindoff have been involved in some work showing that the rapid warming since 1995 in the Indian Ocean reflects stronger flow from the Pacific to the Indian Ocean through the Indonesian archipelago. The top plot shows the increase in temperature, and the bottom plot shows the increase in transport, the big red arrow pointing to the left between Indonesia and Australia. That's the increased flow from the Pacific into the Indian Ocean of warm water, and that's warmed large parts of the South Indian Ocean basin. And given the sensitivity of Australian climate to what happens in the Indian Ocean, this is an important finding. We published a piece last year called Choosing the Future of Antarctica. This was a bit unusual. It was a kind of foresighting exercise where we imagined we were an observer in the year 2070, looking back over the last 50 years of human and climate history and biological history in Antarctica and the Southern Ocean, under both a high emissions and a low emissions scenario. The little symbol on the upper left is the altmetric score. This is a gauge of how much attention it received in the media and social media. That may not be the most important metric for a scientific paper, but it does indicate that this work has really caught the imagination and attention of people. That puts it in the top 5% of all papers published in Nature in the last year, in the top 99% across all journals. Top 1%. Nathan Bindoff is a coordinating lead author on a huge effort, the IPCC Special Report on the Ocean Cryosphere and a Changing Climate. And that the final draft is due today, so Nathan will be a very happy man. The benefits of the project: we've delivered high quality data that really is the cornerstone now, the foundation of analyses of just how the ocean is changing. We've delivered new science which is changing the field and having an impact in that way. We've put quite a lot of effort in communicating our findings to a wide range of users, from one-on-one briefings with parliamentarians to assessments, national and global assessments like State of the Climate, the IPCC, and media and public outreach activities like Writing for the Conversation. We've also provided substantial international leadership to many programs, including Argo, GoShip, and iQuad. What's next? The box on the left repeats what I told you at the start of the talk of what's been delivered in Project 2.4. In Project 5.7, we'll be building on that foundation to further enhance climate quality ocean data sets, provide new insights into the nature, causes, and consequences of ocean change, further improve the realism of Earth system models, and put quite a lot of effort into communicating those findings to users in a way that they can use the information. The outcomes, we believe, will be decision makers that are better armed to cope with the decisions that they need to make about the future. And that new knowledge base that we will communicate and inform them, inform their decisions, will be measurements of how the oceans are changing, what that means for the climate, and through the delivery of better models to deliver improved climate projections. Thanks very much. You can see my phone number and email there. I'm very happy to answer any further questions, or we can wait until I speak to you in late June. Thank you very much.